Welcome to Postgres Open 2013 Lightning Talks, the much awaited, much lauded Lightning Talks. If this is your first time at a Postgres conference, you may not know what a Lightning Talk is. They actually came out of either the Python or the Perl community. Both of them kind of claim origins. But anyway, the point is it's a 5 or 7 minute talk, very short. Any topic of your choosing. We do like that they be related to Postgres for this conference. We will cut you off at 5. Chris here is my timer today. And I do have 10 talks. Got a lot of last minute submissions. Way to meet the deadline, people. At first, we're going to have Catherine showing us IPython.
All right. I'm here to show you your new SQL client. This is the IPython notebook. It's a browser-based environment that lets us combine markdown cells, which are easily converted into good-looking HTML, and executable Python cells. So if I go into one of these Python cells, I'm going to run it with Shift-Enter. I was able to run that Python. It actually executes on a server that's running locally. Okay, well, that's nice, but that's just Python, so that's not that interesting. Fortunately, there's a nice little extension called IPython SQL, and when we load up that extension, we can make a connection to a database, and this connection string looks like a SQL Alchemy connection string because it is. All this really is a pipeline into a SQL Alchemy execute statement. But the nice thing about that is, then once we've made this connection, we can issue more SQL commands, and the results come back in this nice-looking HTML format. But they're not just HTML. There's a special IPython variable, the underscore, which means give me the results of the last cell. So I'm going to assign that into the plays variable in Python so that we can keep hold of it. And now we can take a look at it. Well, there's my data again. It's stored nicely so I can keep on referring to it. But it's not just an HTML table. It's really a nested list in Python. You have a list of lists, one for each row and one for each attribute within the row. And so I can refer to them slicing it in the standard Python way, all the way down to the individual cells. But we also, the result set keeps track of the column names. So those, if you notice, those match the column names from our results. And because of that, within a row, we can also refer to individual items by their column or attribute names. So that's cool. And because we've got it in Python, we can play around and do all the crazy things that we do with Python. Good enough. Assigning to underscore is a little clumsy. If you can get your SQL on a single line, then you can do a direct assignment like this. We skipped the underscore and went straight to assigning our new query results to the variable plays. Supports bind variables. So we're going to stick the string Hamlet into a Python variable. We're going to run another query, but this time we're going to get at that Python variable name, and we're going to treat it as a bind variable. And so we have characters from Hamlet, but everybody does Hamlet. That's such a cliche. Let's do something else. Let's do the Tempest. Okay, now we have Tempest characters. And so the notebook lets us back up, change things, back up again, change things, and yet when we're done with these experiments, we have kind of a continuous narrative. And because of the nice markdown cells, that continuous narrative can become both our documentation and what we'll use to execute this in the future. All right, now I'm going to grab that data again. And it's really easy to make a pandas data frame from that. And if you don't know what a pandas data frame is, you need to look up pandas right now, because it's an awesome data analysis library. So we stuck it into a pandas data frame. And from a pandas data frame, it's really easy in turn to, say, stick that into matplotlib, a Python graphing library. And if you see, those are just 3 short little lines. And what we have is a nice pie chart of how many lines characters in Tempest have spoken. So, IPython Notebook, your new SQL client. Enjoy. And it's a really small package. Got lots of ideas to improve it. If you'd like to send me ideas or contribute, there's a lot more that can be done with this. Thank you.
Are we muted?
No.
We're not. Actually, can you hold on to this because I don't have enough hands.
I know.
Let's see. Can't do video and USB. Awesome. See what I'm doing up there? Pay no attention to that man behind the curtain. So normally when we do lightning talks, we like to do them all from one machine. We are changing this up so that some people can do live demos this go around because live demos are always fun. I'm doing one right now. So PG open NS. Yeah, thank you. Can I not see it? Okay, yeah, it only goes in one direction. Okay. And nothing's happening. Ooh. Okay, and this isn't looking like what I thought it was going to do. Okay, I may need assistance with the Macintosh. Oh yeah, and this is why we do it for. Do you have to resize this?
No.
Dave Page.
That button with the 2 arrows in the top corner maybe? I don't know, I don't use Adobe Reader.
Do you use Macintoshes?
F5.
What?
F5?
F5.
Hit the plus sign.
Yeah, you do.
The green.
F5.
There you go. Do that.
But with
There you go. Is that good?
Is that good? Does that work? No, we still don't have the
Yeah, let me do something really quick.
page down. How many people does it take?
last year, this happened to me as well.
It's tradition.
It is tradition.
Yeah.
It's tradition. Okay.
Also known as Pretzel L. Yay, okay. Now we can get started. Okay, so next we have Ines.
Oh, sorry. Oh, already? No. All right, so the title of my talk is a lie. This is not everything you need to know about NoSQL. I thought I could fit something in 5 minutes, and then I realized you can't. So everything you need to know, and it's a lie about NoSQL. My name is Ines, and I deal with all things data at this company called Engine Yard. And what I want to talk about is like what happens with data when it comes to data scale and data in great volumes, and everything that has to do with NoSQL deals with basically which answers we provide to that question. So when I say great volume, what am I talking about? I'm talking about the volume that, for example, Amazon, Google, and Yahoo had. And in 2006, from 2006 to 2008, they published a few papers on what they were doing with their data strategies. And Amazon, for example, published a Dynamo paper. Google published Bigtable, and then Yahoo published Peanuts. And the reason that these papers matter is because they explain the strategies that are behind different types of data stores, and we now call them NoSQL or big data. So they're very interesting papers. Just go read them if you want to. So when you grab a NoSQL data store, what do you do with it? Like, how do you make sense of it? And most of the time, you end up selecting one based on motivating factors or like trade-offs that you have to make. And they tend to be in, like, for example, what availability needs do you have? Can you afford to even have like seconds of downtime? What is your querying story? What is your operational story? Or even just like what data model do you want to, like, does your data get generated in? So this is a very quick chart just to kind of illustrate the point that other than relational, there are other data models that this repository these data stores cater to. For example, you have key value data stores, you have document-oriented databases, column-oriented, and graph. And what they attempt to do is reduce the impedance mismatch. So I always pronounce this wrong. Impedance mismatch, and basically this means that it brings data closer to the format that is generated. So let's go through a few of them. So I don't know if you guys have heard of Redis. So my goal here is to kind of like show you maybe 4 of the more important ones and show you where it fits. So Redis is a data type server, and it comes with operations that are optimized for example, like sorted list or unsorted list. It's really, really fast. It's best, and most of these data stores are best if your entire data set fits in memory. And people are mostly using it for caching. We use it for worker management, and it's very, very pervasive in like the Ruby and such like environments. So we use it a lot. Our customers use it a lot. You have MongoDB, and this is another one of the really popular ones. And MongoDB is a document-oriented database, and it means that you can shove it something that looks like a JSON document, and then it understands it. And it's fastish. If you don't care a lot about durability, it's fastish. And it's also best if your data fits in memory. The model is like a primary, secondary. This big disadvantage with Mongo is that it has a global write lock. So you're going to get choked on writes fairly quickly, and then you have to shard, and the sharded installation is not necessarily like super amazing for operations. Then you have something like React, and React is a complete ring. Every node in a React cluster is the same responsibility, it's exactly the same. So it's built for like very high fault tolerance. So in React, you can afford to lose nodes, and they just may not be functional, but your operation, you continue to operate and you continue to serve data. And the ops story is pretty great. And then, for example, you have like knwo. And knwo is a database that is optimized for nodes and connections. So if I wanted to say, give me the friends of a friends of a friends that also like this thing, then a database like knwo makes that fairly straightforward. But so there's many things, and I only covered 4. There's just like tons. So you have Hadoop, you have the HBases, you have like your caches and your other searches. But why do you even bother? And I think that I covered this already. You bother because you're following the holiest of grails. So just like building your application in a service-oriented architecture and a service-oriented pattern. This means that you are able to encapsulate your data store around with a service that makes it very interchangeable for you to be able to just like you maybe want to put a key value data store on something where like you don't necessarily need ACID guarantees, or if you have a recommendation engine, you may choose a data store that helps you just return these values faster and make these computations like much more straightforward. So I left a lot out. So if you have any questions, that's what I've been doing for a while. So yes, you.
What, if anything, do you think that we have to learn from these other databases, or perhaps, is something for us to learn from them, or is it like, well, they can deal with those sorts of problems and that's okay?
I think that they're actually like it's very strange. So for me, it's like you have to wrap around. You have to understand that there are other models that people are using. I think it's important to know why they're using it, and then how you can leverage. Done. Sorry. So no questions until. No questions.
No more photos. Yay, thank you. So, yeah, like I'm afraid to touch this thing now. So, you need a web browser, right? Would you like Chrome or Safari?
Chrome.
See, I'm giving you a choice here. Now, does this look right?
Yeah,
Yes,
yes,
amazingly.
oh, sure.
Okay, so next we have Kirk, and you were talking about extensions in Postgres. Yes.
Howdy. We've heard a lot about Postgres extensions here in the last few days. I've heard probably the word extensions about 20 times, and I'm pretty sure that somebody around here is going to go, well, I needs to get me some of them extensions. There must be some. How do I mix me one, and how do I actually publish this and package it in any way that makes any sense? Well, let's start with this handy little website made by several people were contributed to this thing. It's called PGXN, and PGXN is all about. Ooh. No. I think we're having issues with. Our provider here. Let's see if we're back on the internet now. Take off the S. Okay, here we go. Yay, PGXN. Okay, and PGXN is actually here explicitly for this, for you to share and bring out your extensions to the world. And if you look in the handy-dandy facts section here, they actually put all the documentation that matters in this nifty little place. And about halfway down the fact, they actually tell you how to install the client that will let you install PostgreSQL extensions. So this is the way to, and this little library is written in Ruby. So this is a Python thing here, and it installs this little Python client, and it works a lot like apt or it works a lot like apt or Yum or any of the other repository managers, and allows you to install and uninstall extensions, as well as also load them into Postgres in the same way that you'd say create extension, blah, 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 in Postgres. Well, that tells you how to get some. Well, how do you get them out here so that somebody else can get it? And that's it. And that is, you find this, you find a handy little thing over here at GitHub. And on GitHub, we have this thing called the PGXN util, right? And PGXN utils is a little Ruby gem, and when you install the PGXN util, it does a really handy thing for you. It says, you say PGXN util skeleton, make me a neat, cool extension. And it builds a directory structure for you and puts all of the nifty things in there that you're going to need in order to make your extension, and make it in a way that you can also version it, and that you can semantically version it for Postgres so that you can update it later as an extension. And then it tells you, and then it does the nifty thing here where it tells you how to change something and then to publish it again. And then it will tell you how to bundle it up into a nice zip file, and then how to release it on the PGXN network. Put in your username and password and install it over there on the PGXN network so that everybody can get around to it. So the two pieces of this are basically the PGXN utils, which tells you how to create one, how to update one, and how to publish it. And then the network, where it tells you how to download and update and install it for yourself. And then we have over here, in case you want a place to go and find all that written out in a nice form, we have, we go to Amazon and we find a thing called PostgreSQL Server Programming. Oops. Right? And we find out that some schmuck actually anticipated that you might ask that question and try to figure out how to publish an extension, and wrote a book on it. I think you're going to want to read chapter 8. I'm out of material. I'm out of time.
Thank you, Kirk. Is Mark with the all-consonant last name here? Yes. He's going to talk about config management. And you just needed a browser as well, right?
Yep.
Excellent. There you go.
Hey, I'm Mark Mzyk. The last name is Mzyk, hence the comment. But so how many people in this room know what config management is? All right, and how many people went to the Puppet Talk? And how many people went to the Puppet Talk and don't know what config management is? All right, I was going to say anyone that fell in that category was going to be a liar. So the idea of config management, you have this suite of tools. There are currently 5 major ones: CF Engine, Chef, Puppet, Ansible, Salt. I work for OpsCode. We make Chef, full disclosure. The thing with the tools is it's meant to be an easy, repeatable way to do setup. So it's not something that you would necessarily be like a Postgres tool, but you would use this to set up Postgres. You configure Postgres. It allows you to install Postgres and to write a configuration on it. And then you simply would say run Chef or Puppet on your server, and it makes sure Postgres is there. It makes sure all the tooling is there. It makes sure all your configs are in place, so you have full control. You write these things. And it's meant to make it so that your servers, if you have a fleet, you make them so they kind of look the same. It's a repeatable process. It's idempotent. So why do you guys, particularly care? So it turns out all these tools are open source. They all have open source components. And then we have things like, say, the community site. I'm just going to set this down because I like to talk with 2 hands, or type with 2 hands. So we go to the community site, and what this is it's our cookbooks, what we call our parlance for recipes that you can deploy these servers, and you see we have one for Postgres. And so using in Chef, you can download this, you can deploy it out on your servers. But my plea to you guys is people have written this, you can see that thousands of people have downloaded this and used it. That doesn't necessarily mean it's great. In this case, what we have, if we actually look at some of the files, you can see it will install on various Linux platforms. It sets up various configs default out of the box. You can, of course, take this and change it. The thing is, the people who have written this are probably not Postgres experts. So if you guys want to help make Postgres better in the world, you can find this. Puppet has a similar thing. Most of the tools have a similar thing where you can update this and you can help people get a better experience with Postgres out of the box. Because a lot of companies use this. A lot of companies use these toolings to manage their fleet of servers. And so my appeal to you here is, let's use this to make the world a better place. And so this is just kind of the general one that's available. And if we look at, how would you contribute back? Well, all this lives on GitHub. And so we can actually go. There was a merge that's near the top because there was a merge done today. Here's what I was just showing you a minute ago. This is the Chef one that will run in. And here's where you can do pull requests, so you can see all the issues that we actually currently have with it. But so I encourage you, if you don't know what configuration management is or you're interested in it, you can speak to me. I'll explain it more further to you. But so my basic request from you guys is help contribute back, help us make all this better, contribute to the open source world. So, yeah.
So my complaint about the code that you showed them a second ago,
Yeah.
there's no comments explaining why those settings were chosen.
Okay.
And that doesn't require being an expert. That's just why wouldn't it, for example, why does Devlin need a smaller shared buffer setting than that?
And that I don't know.
Which is
Well, yeah, exactly.
The bigger question, why have the same connection, back connection to Postgres? Right? Like, why wouldn't you move out the common stuff? So anyway.
So, why would you specify it at all?
this doesn't make sense. Let's help them.
Complaining about I can fix it.
No, so my complaint is not about the specific settings. My complaint is like whoever wrote this should have been at least explaining why they wrote what they wrote.
Okay.
An expert, because I can't change it now because I don't know why it was chosen to be this way first.
Right, so in these cases, like our default community ones are generally shared. In this one, ops code actually maintains it, in this case for Chef. And I can't explain to you exactly why things were picked, but you can always submit pull requests back, communicate to us, and we'll do our best to update it. It's certainly work in progress.
Thank you, Mark. And the Postgres community. Thank you. So next up we have Jonathan Katz. Maybe. Where is he? There he is. Okay. So if there's anything wrong with his slides, it is my fault because I had to convert them to PDF from OpenOffice.
It's embarrassing.
So
Does the clicker work?
I don't.
Do I need a mic?
You don't have to use a mic if you don't
I mean,
want
are
to.
they recording it?
Are you all recording this?
Okay.
Yes. So here, okay,
Oh, the
watch
click- the
this
click is
pretzel
the-
L.
Oh, yeah, the click is not
Ooh,
working.
see?
Okay, so we're going to talk about three things that have a lot to do with each other: JSON, speed, and user groups, because we can all see the relation. So, as we know, Postgres added JSON support in version 9.2 and added much better support for it in 9.3, basically, allowing us to run these things called functions. And because we have functions, we can actually extract the data out of our JSON elements and do comparisons on it. So I created a table with a million JSON records in it, and you probably notice it's an unlocked table because I like to live by the seat of my pants. But what happens is I can do comparisons and actually see what information is in it, which is good because let's say I pulled stuff from a web API and there are IDs in it. I might want to be able to find everything with an ID of 30 and pull it out. But when I'm running this query, it's kind of like running a Ford Model T. It works, but you're not going to get anywhere very quickly. It took almost a second to find this. But because we have functions now, we can take advantage of expression indices and basically point exactly at, and in this case I have to point at the exact JSON element I want to pull out. But as you notice by our explain plan that we're hitting this index and we're more like a McLaren MP412C. We're pretty fast. I mean, that's an order of magnitude of 4 speed up. That's like big numbers. So start using it, by the way, if you need to pull your data out of JSON. With that said, let's get into user groups. Another thing that grew very quickly, much quicker than I thought it would, was the New York City Postgres user group. And as much as I like to say that it was by accident and we had no idea what we were doing, we had a little bit of an idea. And what's great about it is that community building, for instance, having a Postgres open conference is the best way for people to learn cool things like how to write McLaren MP412C queries. So what's the first thing you do? The first thing you do to start a user group is email the advocacy list or check this list right here to see if there's any user groups available in your locale. And if there's not, well, if there's one, you should join it and participate because it's a lot of fun. And if it's not, you should start it up. Because the first step is you got to get people together. And the easiest way to get people in the Postgres community together is beer. Or wine, or root beer. Because when you do have beer, they will come. And they've heard this before, but Steve and Dave will definitely come. And once you have them there, you can basically, once you have people together and you realize you have a stable user group, there are these 4 organizations and probably more that are nonprofits and that have funds to help support the group, help you bring in speakers, such as Bruce, and to talk about topics and get things kicked off. Bruce talking about Postgres 9.2 or in a couple of weeks 9.3 in New York can draw people there and help grow the group further and outreach to the other user groups, the Python groups, the Ruby groups, even the MySQL groups, and get people using Postgres. The other key thing is to have a consistent schedule. Now your location might not be like in New York where it's easy to have one once a month but having something regularly, once a quarter, once every half year, and just people expecting to these meetups to happen. Of course, you got to keep coming up with ideas. Here's a cheat sheet. What's new in Postgres? Why did this company use Postgres? What's a Hadoop with, what's it like to use Postgres with Hadoop? It's a great way to build a community because you can outreach to all these other different organizations and pull them all together. And if you run out of ideas, just find a really sweet rooftop and get someone to sponsor beer. This ultimately leads to having a regional conference. Once you have sort of that critical mass, you can try bringing in people from around the world and get the experts to come in, and also just further expand what's going on in your local community and learning better ways to use Postgres. And this leads to the larger conferences, like a Postgres Open, which had a record number of attendees this year. PGCon had 240. PGCon EU had 290 last year, and we'll see if they can break that number as well. I think what was the number again for Open? It's like 157. It's pretty cool. And that ultimately means there's more beer for everyone because more people using it. There's more sponsorship in the community, and everyone's happy. Thank you.
Thanks, Jonathan. I've had to change my speaker schedule a little bit. Andrew, surprise, you're next. Do you want the mic?
Hi. If you're at PGCon, you've seen this, and I apologize, but I thought it might be interesting for some other people. We're here to talk about a new foreign data wrapper, the black hole foreign data wrapper. So, have you ever worried about whether you've got too much data? Now, we've heard a lot about big data, and I'm here to solve all your problems. Have you ever worried where your next piece of hardware is coming from? Maybe budgets are a bit tight. Stop worrying. Sometimes getting the right answer just takes too long, involves too much resources, too much space. We're going to get rid of all those problems. Stop worrying. Just put your data in the black hole. That's the black hole foreign data wrapper, and it actually exists. You can get it there on Bitbucket, and I'm going to tell you about some of its actually really cool features. It has absolutely brilliant data compression. Unbeatable. There will be no unintentional data loss. Speed can't be beaten. Here's what it looks like. And as you can see, we're not storing anything, but we're doing it really fast. So, on a lighter note, it's actually fully functional, if completely useless. But it was I actually created it with a slightly serious purpose, which was to provide a skeleton foreign data wrapper which can be used to write real ones. And it's got some logging stuff involved in it and some other things. So if you're actually interested in writing a foreign data wrapper, this would actually kind of help you, particularly the new writable ones where the API is takes a bit of getting used to. I'm still trying to get my head around how to write actually functional ones, but this has actually helped me quite a lot along the road. So it was done as a joke, but it's had its useful side. So if this is actually not true because this is not PGCon. If you if you want to see something about JSON, then come and see my talk tomorrow. And we've heard a lot about that today. But you can go to Bitbucket and get this. And please write more foreign data wrappers. We need a lot more, particularly ones that support the new update features. Okay, thanks very much.
Thank you, Andrew. Next up, Denish. You here? There he is. Do you want the mic?
I'll use it. Hi, I'm Denish, and I'm going to talk about choosing the D. So, actually, I'm not going to talk about choosing the D. I'm going to talk about choosing the doctor. Oh no, I'm not going to talk about that too. What am I going to talk about? Oh, choosing the database. So, whenever you are going to choose the doctor, I think, what are the top 10 things? We have 5 minutes, right? So, I'm going to talk about only 5 things. Let's talk about top 5 things that needs to be required for choosing a doctor. So first thing, whenever I look for choosing a doctor, I first look for a credibility. Is he really a doctor? Right? Because if you have an eye problem, you are not going to the pediatrist. You are going to the eye doctor. So the same way, when you choose your database, make sure it have the ACID credibility. Everybody knows about ACID, right? I don't want to say the names. Actually, I don't know. The second thing is proximity. Once I found out there are, let's say, 100 doctors around Baltimore, but I am not going to choose somebody from Washington, D.C. It's too far for me. Even though it's 30 miles, it takes 2 hours. So I'm going to choose the one which is available, and I think whenever you choose your database, you should make sure you choose a database that has available resources very close to you, not a closed source or something like that. The third thing is affordability. Even I got a doctor now, I need to make sure that I could afford to have that doctor, right? I can't spend a lot of money on it. So, and it takes insurance, maybe Obamacare, it's free. So always choose a database that is open source. So that's the third thing. The fourth one is maturity, right? Because once you have, like, I chose 3-4 doctors now, you need to make sure that you need to look at the reviews, how doctor is doing, like, because you can find a number of sites that provides the reviews. So same thing with the database, make sure you see some case studies who uses that database, like Instagram uses Postgres and they made a lot of money out of it. Number 5, oh, it's number 1. Yeah, customer service should be number 1, right? So if doctor is good and the receptionist is not good, then I don't think so you're gonna choose that. Even though you chose it first, you're gonna move to the different doctor because of the receptionist. So make sure the community should be good. So the one thing you should learn is be nice to everybody. That's it. Thank you.
Thank you. All right, and next up, all the way from Portland, Oregon, my partner in crime, PDX Plug, Mark Wong.
Hi, my name is Mark, but I'm helping this guy out with the presentation. Name is Chelnik. Came all the way from Portland. Registered in the Crimson Lounge. Went to have some deep dish pizza out on one of the dinner tracks. Got to meet a lot of people. Great staff at the desk. Share some root beer. Anyone else from Tufts? Anyone else from MIT? All right. Got to make some good conversation about normalization. Learn how to scale up. Practice some Swedish. Got to be in a Puppet presentation. Replication tips. Try to get the JSON presentation a little early. Loves PG admin. Got to talk about R. Get some workout in. And have a little bit of booze. So, he's sorry if he didn't get to meet you. Has some cousins that have their own website or Tumblr. Looking for a new home, you can pick them up at the charity auction tomorrow in the closing session. Thank you.
Thanks, Mark. All right, now next up we have Greg Smith. And walk slow so I can get the right USB key in there. Crikey. All right. Find her. Eject. Shared. Who's that? There you go. Thank you.
Cool.
Hooray, pretzels. I think that Andrew's talk on the black hole foreign data wrapper, I don't know that it properly credited where all those ideas came from. The first time I saw a black hole storage engine for something as part of MySQL, I think the main reason not that many people know about it is it basically is the same properties as my ISAM, so you know, it's not that big of a deal. I wanted to talk about tools, small tools. A good example to kick that off with is archiving. Postgres expects that you're going to provide a number of small scripts and things to do operations that basically plug into your server. So it's possible to set up replication without archiving, but a lot of people end up wanting that as part of disaster recovery and everything. And this is the example that's in the manual. It's for Unix systems. It's using this combination of checking if the file's there already, and it has a couple of hard-coded bits in it and whatnot. And so you might look at this and go, okay, well, this is like a couple of commands chained together. How many bugs or problems could there possibly be when you go into production with this? And the answer is so many of them. You build this stuff in the real world, and things like the simple archive command that just run a simple line thing like that really doesn't work out so well. What you want to do in the real world is error checking, make sure that the directories you're copying to make sense. There's things like logging you have to be concerned about, and the people that have tried to propose solutions to this stuff have mostly been as part of like larger toolkits. And when you build a larger toolkit, people tend to not be too excited about that because now they've got another piece of software they have to install. So what everybody does instead is write their own little brand new script from scratch, and they're back to the bugs again. So there's a lot of these things in Postgres. It's just a little harder to get them right than you might think. For example, table statistics. People go, oh, I want to monitor the hit percent on my cache efficiency. So they'll write some report up and everything will be cool, and you run this thing, deploy it into production, and in the real world, this is actually what happens the first time you run it. So all of these things are not difficult to do. They're just, you have to fight with them for a bit in the real world. And one of the things I think the Postgres community has been missing is a good way to take all these little mini tools and kind of make them easier to get a hold of. So I just put something up on GitHub this week. I have a community-oriented Postgres blog at High Performance PostgreSQL. So I sort of said, let me take the kind of tools that I use on a day-to-day basis and publish them there, and then we don't have to get people doing the same things over and over again. So like here's an example. Here's the archive wall command that I have. It's got a standard command line interface to it. It takes parameters. You can save things locally, you can save them remotely. It's got some debugging stuff in it. It'll save to syslog, which you'll discover is actually something that doesn't work right in the regular setup. And you can even toggle on things like validating that the thing appeared on the other side if you just don't trust anything, or you're saving stuff to the cloud and you discover that periodically files say they get written and then they're just not there when you check them later, which is also a thing that totally happens. I've also taken some of the little performance monitoring snippets that I've written. There was a really neat thing in Postgres recently where you can now get when the statistics in the database were last reset. That happened in Postgres 9.1. What's neat about that is if you know when it was last reset and the server's been up the whole time, you can derive all sorts of statistics that are like averages over the whole time. So one of the little tools in the kit shows you not just these weird counters from the background writer, but like how many megabits per second that represents in real world units. So I mean, this is a lot easier to interpret and immediately get something useful. It used to be that you had to grab a couple of snapshots of background writer activity and get the delta and all this other stuff, but the statistics thing makes this a lot easier to deal with, and these numbers are much more useful. Same sort of thing is possible now in just general statistics. You can write a query that tells how many rows per second are happening or anything else, and that's what it'll look like. And that's it.
Thanks, Greg. Okay, so we are now going to have another live demo. You guys ready? Tom and Dave from EDB. Oh yeah, nice. Are going to show us PEM.
Hello. Is this on? Oh, there we go. Okay, so I'm Dave, this is Tom. We're going to give you a quick run through of some of the features in Postgres Enterprise Manager. So, PEM. It's an enterprise DB tool for DBAs and developers designed to manage, monitor, and help you tune both community Postgres and our Postgres Plus Advanced server products. Anything from one server up to many, many servers. So manage, when we say manage, we mean you can add, delete, change objects, basically all the stuff you do in pgadmin. But on top of that, you can also do various other things. You can edit configuration files, configure auto vacuum, that sort of thing. Much of that will be fairly familiar if you've ever used pgadmin. What we also add is monitoring. So we have an agent that runs on your servers. It can monitor one or more database clusters on each machine, and it sits there continually collecting database statistics about various different things and operating system level statistics. Collects all that data, sticks it in a database so we can use it later. We can use it for capacity management, so you can draw pretty little graphs that are showing you your disk usage. You can do things like extrapolate out those graphs so you can see when you're going to run out of space, that sort of thing. We can also do configuration management, so we have tools in there to allow you to set up logging, audit logging, and so on en masse across your entire array of servers. You can run alerting from the statistics that are collected. So if you find things that are out of whack, we can send SNMP traps or emails, tell you what's going wrong so you can go and investigate further. Logging and audit management, just mentioned. SQL profiling will help you analyze the SQL as it's running through your database server so you can see why queries are running slowly. You can see what queries in your workload are taking the most CPU and I/O resources, etc. And we've got obviously debugging for procedural languages, which has recently been rewritten and added back into community Postgres, community pgadmin. And finally, tuning. Edit all your tuning parameters en masse throughout the system. We have tools that will help you analyze and figure out sort of standard base configurations and deploy those automatically. Profiling of and inspecting the SQL workloads in the profiler, and debugging and rewriting queries. You know, not only can we does it help you debug, but it will also help you figure out things like where you need indexes. And at this point, I'll hand you over to my glamorous assistant for a quick demo.
All right. Thank you very much, Dave. And it's got to be 2 minutes and 15 seconds this demo, so if you can do that.
Come on, Tom. No pressure.
No, I know. Where's my demo? It's here. I don't know.
It's on this screen.
It's on this screen. Should we unplug
So
it?
if you all want to crowd round here and
Just gonna come up and take a peek.
yeah,
Let's see.
can you get back to the other screen?
Yes, I see.
Go to preferences.
Let's see.
Right a bit. Right.
There we go.
There you go. Left a bit. There we go.
All right. Just be a demo on how to change the screen there. Okay. There's a display.
Left a bit.
There you go. Show me arrangement. Where is it? Okay.
All right.
Awesome. Ah, all right. Now, all right. It's going to be a little bit different resolution than I planned. Okay, so where I am, let's see if we can. All right, it's a slightly different resolution back home when I practice this. But what this is showing, this is the PEM console, and it's showing me I have 3 servers that are up, 1 that are down, and it's telling me all the alerts that I have on a particular server. And these are alerts that I set up. I can have alerts for things like my vacuum hasn't run frequently enough. I started using index scans as opposed to sequential scans, all sorts of things that I can pre-configure. So I'm going to just demo one particular feature, and that's the SQL profiler. Those of you who want to come see more of the features later, come by, find me. I'll be at the EDB booth. Okay? Time? No. All right. Well, is it time? All right. Come find me. I'll show you all the great things about PEM and on one screen. So, all right.
Yes, we do have strict 5-minute
All right.
rules. Thanks. So that was the lightning talks. Thank you very much, especially the people who totally sent me a bunch of stuff at like 5 minutes before the talks because they heard that I only had 5. So that was awesome. I do love the way this community pulls together.